everybody. We're in our second to last lesson of the year, and we're going to do some graphing of sine. I know you guys can't wait. So the good thing is some of these ideas are things you've seen before with other types of transformations. We're going to be doing transformations. So if you guys remember, every function has a parent function. The parent function is the no frills, plain old function. And notice, instead of x, we're using theta. Theta is just x, basically, but we're specifying that it's the angle, that x in this case is actually an angle. So if you guys probably recognize these as radian measures. So if you look at your unit circle, and remember the sine is the y coordinate. You guys just took a quiz about this. So if I go and I look at 0 on the unit circle, the y coordinate is 0. Right? If I go to pi over 2 on the unit circle, the y coordinate is 1. If I go around a little more to pi, I get back to 0 for the y coordinate. Down to 3 pi over 2, I'm at -1, and then 2 pi, I'm back to 0. So this is what we're going to call the parent y values, and I'm going to do a shorthand here. I'm going to call that y parent. And the parent x values, okay, parent theta values, I'm just going to call that theta parent, okay? So this is our parent function, and I'm sure you're all curious, what does the sine curve look like, right? We know parabolas are shaped like U's and absolute values are shaped like V's. Well, let's graph these points. Notice my x-axis is now radians instead of values of x like I'm used to. So I'm going to graph 0, 0. I'm going to graph pi over 2, comma 1. I'm going to graph pi, comma 0, 3 pi over 2, comma -1, and 2 pi. And notice, guys, sometimes you'll see, okay, I want you to keep going with this pattern. Even though our table ends at 2 pi, I really could just keep following the pattern, right? I could keep going. Looks prettier when we fill in the whole graph. So that's our sine curve, the parent table for sine and the parent graph for sine. Now here's the thing. You guys have seen A, B, H, and K before. So I'm going to remind you what each of these does to our parent table. Remember, our parent table is our anchor. It's where we start, right? Everything that happens here happens to the parent table. So if you guys remember A is vertical, stretch, or compression. So what happens when I have an A value, right? Well, what that means in my actual table is I'm going to multiply the parent y's, I'm calling them yp, by A. So if there's a 3 there, I'm going to multiply all those guys by 3. Now, if you remember, B is a little bit weird, right? Anything inside the function affects the x, or the theta. So B, that's horizontal stretch or compression. And which makes sense because it's inside the function. However, remember there's this funky thing here. I'm going to multiply the theta parent not by B, but by the reciprocal of B. So this probably sounds familiar, right? We've done that with other functions. Okay, notice, guys, the h is also inside the function with the theta. So h is horizontal, oh, not that pen, horizontal shift. Right, so it's horizontal shift. And what I'm going to do here is I'm going to add h to the theta parent. Each value in the theta parent table. And then last but not least, k is vertical shift. And what I'm going to do there is add k to the y parent values. Right? So I've got 4 different things going on here. 2 extra things we need to be able to identify when it's a trig function. One is called amplitude, right? And amplitude in the equation is just equal to the absolute value of A, right? So technically, what it is the distance from the midline to the top of the maximum and the minimum, right? So up here, this is amplitude right here. That's amplitude. So the way I like to think of it is how high are the mountains and how deep are the valleys? So how high the mountains are or how deep the valleys are. Okay, so that's another thing you'll be asked to identify. The other is the period. And the period is basically the length of one cycle of the sine graph. Oh, yes, I can spell cycle. Okay, so I can see it. This is basically one period right here. Right, because then it's going to, right, repeat itself after that. So the way I do that in the equation is my period is equal to 2 pi over b, right? So amplitude is absolute value of A, and period is 2 pi over b. Okay guys, are you ready? The big moment. We are going to actually graph some now. So I'm just going to remind you what we want to do is look at our parent table as our grounding, right? That's where we're going to make our transformations. So this first one we want to graph is 4 times sine 2 theta plus 3. So what I'm going to do is I'm going to go here and I'm going to identify, I'm going to look at this and I'm going to say, okay, this is an A value. 4 is an A value, 2 is a B value, and 3 is a K value. Now, how do I know it's a K and not an H? Well, if it were an H, that theta would have to be in parentheses with the H. So let's see, we have an A, B, and a K. So A and K affect the Y parent. Right, so what I'm going to do here is I'm going to take the Y parent, I'll lay myself much room, I'm going to do 4 times the Y parent minus 3. Sorry, not minus, plus 3. Right, so I'm going to take all of the parent values in the Y table and I'm going to multiply them times 4 and then add 3. So I've got 4 times 0 plus 3, right, because look up there, that's, or sorry, you can't see it there. But if you look at your parent values, right, these are my parent values right here. 4 times -1 plus 3, and 4 times 0 plus 3. And those are going to be my new values here, right? So this is going to be 3, 7, 3, -1, and 3. Now, here's the thing. Some people don't like this part because you got pi's involved there, but you will get used to the pi's. Okay, so the B, remember, that I have to multiply all the theta parent values by the reciprocal of B. So the reciprocal of 2 is 1/2. So let's multiply every single theta parent value. Again, these are my theta parent values. Okay, and then, right, so when I multiply, well, 1/2 times 0 is 0, right? The pi just stays pi, right? So if I multiply 1 times pi, I just get pi. And here I'm going to multiply and get pi over 4, right? Here I'm going to get 1/2 pi or pi over 2. Again, I'll multiply straight across, 3 pi over 4. And this, it helps sometimes to go like put a 1 under if it's not a fraction. This is 2 pi over 2, which is just pi. So here's my new table, right? And I'm going to graph it. And I'm going to see, okay, how does this look different than the parent? So your graph has a little more room. Notice, guys, right, I could keep going with this pattern. Notice how stretched out it is. It's much thinner and more stretched out, right? So I could keep going with this if I wanted. I could go, yes, like this. Even though those aren't on my table, I could still draw them. It looks so pretty when I do that. Okay, right? So instead of describing the transformations, we are going to identify the amplitude and the period. So the amplitude, if you remember from a few moments ago, the amplitude is the absolute value of A, right? So the amplitude is the absolute value of 4, which is 4. And the period is 2 pi over B, right? And B is 2. Okay, guys, and I want to point out something kind of cool. Look, I can see in my table that one period is pi. It starts at 0 and it goes to pi. And then I would just repeat, right? I would just keep repeating the same pattern over and over, right? So one cycle we call a period. Okay, let's make it a little tougher. We're going to put an H in there. That's always fun. So I'm going to identify this. This is an A. This is a B, this is an H, right? Because I can see it's inside the parentheses with the theta. So again, let's do the Y first, it's always a little easier. I'm going to take, A is going to be the thing that affects my Y here. There's no K on the end, so I'm just going to take all my Y parent values and multiply them times 3. So 3 times 0, 3 times 1, 3 times 0, 3 times negative 1, and 3 times 0. So these are my new Y values. Okay, here is the fractiony stuff that people tend to not like. Okay, B, remember I'm going to multiply the theta parents by the reciprocal of B. So that's 2 theta parent. And then this is the part that's not super popular. This says minus pi over 2, but you guys remember that funky thing when it's a minus, we're actually going to add pi over 2. Okay, let's do this. So with 0, right, I can say, right, the first value is not so bad doing the math, right? So 2 times 0 is 0, plus pi over 2 is pi over 2. Here's the part where people don't like it. 2 times the second parent value is pi over 2 plus pi over 2. Okay, guys, so I want to come over here for a sec. How do I do 2 pi over 2 plus pi over 2? Well, let's see. 2 pi over 2 is 2 pi over 2 plus pi over 2. Right, guys? So if I think about this, this is just, I can add the pi's. They're like terms. So I can add the pi's, 2 pi plus pi is 3 pi, and keep the denominator the same. That's what I do when I add fractions. I add the numerators and keep the denominator the same. So this one's 3 pi over 2. Now what's cool about this is once I see a pattern, I don't have to keep doing this, right? So now I'm going to do 2 times pi plus pi over 2. Okay, this is the one people don't like because now I don't have a common denominator. Now I got to get a common denominator. So 2 times pi, right, plus pi over 2. Well, we got to change that to a denominator of 2. So that gives me 4 pi over 2 plus pi over 2. And that's going to give me 5 pi over 2. Okay, some of you might be seeing the pattern by now, but we'll just do the rest of this. Does everyone see that's 1 pi over 2, 3 pi over 2, 5 pi over 2. Guess what the next one's going to be? 7 pi over 2. And then 9 pi over 2. But let's try one more with the multiplication just for fun. Okay, so now I've got 2 times 3 pi over 2 plus pi over 2. Right? So that's going to be, up here, 6 pi over 2 plus pi over 2, which is 7 pi over 2. Right? And like I said, once you see the pattern, you don't have to keep plugging it all in. Right? It's just helpful for the first few. Okay, let's graph this. Let's see what it looks like. Gotta erase this. Okay. So we've got pi over 2 comma 0. Oh, I didn't mark this. Okay, then we've got 3 pi over 2 comma 3. We've got 5 pi over 2 comma 0. Notice this is more stretched out, right? 7 pi over 2 negative 3. And that's because we've done a horizontal stretch on this. Oh, sorry, I did this wrong. Pi over 2, 0. This is it. Okay, so this is what it looks like. Right? So notice, now it started a little bit to the right because we shifted it. Okay, guys, we need amplitude and period. Amplitude is the absolute value of A. So it's absolute value of 3, which is 3. Right? And the period is 2 pi over b, right? So 2 pi over b, so that's 2 pi over 1/2, right? Which is 2 pi over 1 times the reciprocal, and that's going to give me a period of 4 pi. And notice, guys, I can look at the table, and I can see the difference between pi over 2 and 9 pi over 2 is 4 pi. So I can actually look at it at the table as well and see what the period is. Okay, guys, so here we had equations and we made graphs. What about if we have a description and we're asked to make an equation? So we have done this with transformations before, but this one's a little different. Remember, you guys like my Brindley super duper method where I just say, okay, I'm going to write down, I know I'm going to have to just start putting the pieces in here, right? So I've got theta, maybe I'll have an h and a k. So first they tell me that it's reflected across the x-axis. So remember what happens when something's reflected across the x-axis. That means there's a minus sign in front of it. Okay, it also says it has a period of 6 pi. Okay, that we haven't seen before. A period of 6 pi. So that means we need to find a b value. So the period is equal to 2 pi over b. Right? And we know that the period is 6 pi. So let's solve that equation, guys. Let's multiply both sides by b. So I get b times 6 pi equals 2 pi. And then I'm going to divide both sides by 6 pi. And I get b equals 1/3. Right? The pi's cancel. B equals 1/3. So that means there's a 1/3 right here. Right? Because we just found b. It says there's a shift left 3 pi over 4. So remember that weird thing, even though it's left, that's going to say plus 3 pi over 4. Sorry, I didn't leave myself enough room here. And then it says it's up 1 unit. So I'm going to have a 1 on the end. So this is my equation based on that description. Okay, so we've got equation to graph, description to equation, and now we're going to do graph to equation. So first they want me to identify the amplitude and the period. So I'm just going to draw it right on the graph itself. So remember, the amplitude is how high is the mountain or how low is the valley. So there's my amplitude. Right, there's my amplitude. There's my amplitude. These are all my amplitudes. So what is the amplitude? Well, this is 1, 2, 3, 4. So it looks like my amplitude equals 4 here. Okay, so the amplitude equals 4. Actually, I probably should write it over here. Sorry. Here's my amplitude. Okay, my period, the reason I erased that is because the way I do the period is I go either mountain to mountain or valley to valley, right? Because sometimes it's hard to visualize. My period is one cycle. So it's where it goes one cycle of going up, down, and back around, right? And then it starts over again. So I can see here my period is 4 pi. Right? The other way I can do it, depending on how your mind likes to think, is I can also look at the period as mountain to mountain or valley to valley. Do you guys see here, if my first mountain is at pi, my second mountain is at 5 pi. So I can see the period is 4 pi. Okay, so they want us to take this information and write an equation. Now, very important information here. They're saying assume there are no horizontal or vertical shifts, right? Because that would mess everything up. So I know that I'm just going to have an A and a B, right? No H or K here. So there's 2 things I need to know, right? I need to know what B is and what A is. Well, A is just the amplitude, right? So in this case, my amplitude, I can see, is 4. But what about my period? Well, I know my period's 4 pi, right? But I need to know the B value. So watch what I'm going to do. I'm just going to put 4 pi in here, and then I'm going to solve that. Right? And that's going to give me my B value. So if I multiply both sides by B, cancels out here, and I get B times 4 pi equals 2 pi. And then I'm going to divide by 4 pi, and I'm going to get B equals 1/2. So now I know B, and I know A. Right? And once I know those 2 things, I can just write it in the equation. So here's my equation. Y equals 4 times sine 1/2 theta. No H or K in the picture. Okay guys, that's it for 9.4a. Have fun with the practice problems. I'll see you guys soon.